One of the best features of AutoCAD is its ability to work with third-party aerial images, such as those from commercial mapping companies or other GIS sources. And when I say work with, I mean bring them into the program, plot your GPS points on them, and send all of it into AutoCAD with everything drawn where it should be. This video is all about showing you how to do this with images saved from Google Earth. It's really an easy process, but it does take a little bit of instruction the first time through. After that, you'll be off and running. So let's get started. The first step is to open up Google Earth and check the settings. There's only one that we have to worry about, which is how the program displays latitude and longitude. This setting needs to match the same way that you display them in AutoCAD. My favorite is decimal degrees because they're easier to type and to work with. So go to Tools, Options, and select the 3D View tab. Look for the Show Lat-Long group and select decimal degrees. For all other settings, use the default value. You may be wondering about matching the datum of Google Earth with that in AutoCAD. Fortunately, you don't have to worry about it because Google Earth works with the WGS84 datum, which is the same as what your GPS uses internally, and it's the same as what AutoCAD works with. For general layout, you can close the Layers panel, but the Places panel will be handy to keep open. The next step is to zoom into the general area that you will be working with, the same area that surrounds the GPS points that you have collected. I've already populated that in my Places panel, so I'll go to it simply by clicking on that node. Here's the region I'm working on. It's a neighborhood in Phoenix, Arizona, where I've collected several points on my GPS unit. Just a side note here. It looks a little like I'm trying to set up an accurate survey drawing, but I'm not. I'm only using this region because I was able to walk the streets and collect points without getting run over. You should always remember the accuracy limitations of the GPS you're using and match them to the requirements of the job you're doing. Back to the exercise. Make sure the map is zoomed to the scale you want and the coverage you need plus a little extra. The process here is that we need to calibrate this image with known points. When I move the cursor over the map, there's a readout at the bottom of the image showing the latitude and longitude of the pointer. These are the numbers that we will use, so make sure your window is sized correctly to view them. I'm going to use two calibration points, one in the upper left corner and one towards the lower right. To do this, I click the Push Pin button on the toolbar, and a default point appears in the center of the screen. Along with that is an information window that pops up. First, I left-click on the point to select it, and then move it to the place that I want it. In this case, I'm going to move it to the center of this intersection. On the Information panel, I'll click in the name box and give it a name. I call it Calibration 1. The default icon is a push pin. This is a little confusing for what we're doing, so change it to something more accurate. I usually use a bullseye. The location changed a little bit, so let me readjust the point. There, that's closer to what I want. The next step is to capture the latitude and longitude of the point. On the bottom of the screen is a constant readout of the pointer location. This readout contains many more decimal places than what appeared in the earlier window. So what I'll do is to hover the mouse over the calibration point and write down the numbers. I show a latitude of 33.596350 degrees and a longitude of -112 .151297 degrees. I could keep this on a piece of paper, but what I like to do is to place it in the point name. To do this, I'll left-click on the point and then select the Edit and the Properties menu. In the name box, I just substitute the latitude and longitude information for the name. Click OK, and now I have the first calibration point set up with the proper information. For the second calibration point, I simply repeat the process for a point near the lower right of the image. I'll show you how quickly it can go. The labels are placed to the right of the point, so I had to select a point far enough from the edge so that the information wouldn't be clipped. Remember though, that these are only name labels and the latitude and longitude values will not be updated if you move the point. At this point, I have all the information needed to correctly register this image with Earth2CAD and AutoCAD. The final step in Google Earth is to save this image. Go to File, Save, Save Image. Give it a name and location. I usually use a desktop because it's easy to find. That's all I need from Google Earth, so I close out the program. This concludes part 1 of using images from Google Earth.